Epochal alignment of planets in 2025. At the end of January and February, two celestial shows will take place, visible almost everywhere in the world. These events will involve all the planets in our solar system in a rare alignment, like beads on a necklace along the thin line of the ecliptic. A planetary parade like this won't be seen again until at least 2040. Will this cosmic event bring disasters, climate changes, or earthquakes? No. As this video from the Insane Curiosity channel will show you, it will bring only beauty. For those of you who are a bit older, boomers as they're often called today, might remember the fuss in the 1970s about an astronomical event that, according to two astronomers who wrote The Jupiter Effect, would bring a series of catastrophes to Earth, including a major earthquake along the San Andreas Fault. The supposed cause was an unusual alignment of all the planets, which would bring Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto into a 95-degree arc in the dawn sky on March 10, 1982. While some took the prediction seriously, others marked the date with end-of-the-world themed parties. And they were right to laugh it off because, of course, nothing happened. The gravitational influences of the planets on Earth are negligible compared to those of the Sun and the Moon. For example, if the Moon's gravitational pull causes a 2-meter or 6.6-foot tide when the Sun's pull is added twice a month, the tide increases to 3 meters or 9.8 feet. Well, to these 3 meters, the force of all the planets combined would add at most a tenth of a millimeter or 0.004 inches. Venus, the closest planet, exerts a tidal force on Earth that is 30,000 times weaker than that of the Moon. Jupiter, the largest planet, exerts a force 200,000 times weaker. Even the combined effects of all the planets on the Sun would be negligible. Their total mass is just over 1,000th of the Sun's mass. At most, their gravitational tug-of-war would cause a solar tide of half a millimeter, or 0.02 inches. Okay, now that we've cleared all that up, let's remember that the solar system consists of 8 planets, which in order of proximity to the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The first 4 are rocky bodies. Jupiter and Saturn are known as gas giants, while the last 2 are ice giants. And just to give you an idea of what we'll be looking at when we gaze up at the sky, let's remember that the average distance of Mercury from the Sun is just 58 million kilometers or 36 million miles, while Neptune orbits at an average of 4.5 billion kilometers or 2.8 billion miles. Earth, on the other hand, is on average 150 million kilometers or 93 million miles from the Sun, what astronomers call an astronomical unit or AU. Then there are the stars as a backdrop. And to avoid scaring you too much, we'll just say that Sirius, the brightest star in the sky and one of the closest to the Sun, is more than 80 trillion kilometers or 50 trillion miles away from us. We tell you all this to better friend the celestial phenomena that you can admire these days, absolutely free from wherever you are in the world. A bunch of planets all in the same part of the sky. Planetary alignments in our solar system are phenomena that occur periodically due to the different orbital speeds of the planets. The inner planets move faster and have less distance to cover, while those from Jupiter onwards move increasingly slower as their distance from the Sun increases. It's like a cycling race on a track, with planets constantly chasing and overtaking each other, forming and breaking groups. When only 2 planets are involved, it's called a conjunction, while a planetary alignment occurs when 3 or more planets, as seen from Earth, are positioned roughly in the same region of the sky. There's another interesting aspect that anyone stepping outside to observe this phenomenon will notice. The planets won't appear randomly grouped, but will line up one after the other. This happens because, unlike comets, the planetary orbits lie almost on the same plane, which is also the plane on which the Earth orbits. This is why the planets involved in the alignment seem to arrange themselves in an arc of several tens of degrees and can be observed together in the same night. We can classify alignments based on which and how many planets we can observe and the width of the arc they form. For example, in the Great Alignment of March 10, 1982, the planets, as seen from Earth, were enclosed in an arc of about 95 degrees. Such a cosmic event is very rare, occurring on average every 175 years. However, other alignments with fewer planets or with planets spread over a wider arc have occurred in subsequent decades. For instance, in the spring of 2000. The next significant alignment involving 5 or more planets won't happen until 2040. It's important to note that alignments are an apparent effect, depending on our point of view. So, while from Earth we see the planets seemingly aligned in these months, from the perspective of an observer outside the solar system, the planets wouldn't be aligned at all. At this point, I hope even the most disinterested among you are a bit curious and have received the basic information to enjoy the cosmic show that the sky will offer in 2 distinct phases, on the evenings of January 25th and February 28th. In reality, weather permitting, the alignments will be visible for several days before and after the indicated dates, with the planets being more or less spaced out, and we will need to consider the time of sunset. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. What makes the phenomena at the beginning of 2025 special and quite rare is that it involves all the planets visible to the naked eye, except Mercury, which in January will set very close to the Sun, making the sky too bright, but it will be visible during the event on February 28th. Additionally, the planets will be confined to a strip of sky just over 100 degrees wide, not too far from the famous alignment of 1982. Starting about an hour after sunset, you will be able to see from left or east to right or west Mars, Jupiter, Uranus, Neptune, Venus, and Saturn. All can be seen with the naked eye except for the 2 ice giants, Uranus and Neptune, for which you will need a telescope or a powerful binocular. The event on January 25th will be a preview of the great planetary alignment awaiting for us on February 28th, during which 7 planets will be in parade. That is, all the planets of the solar system, except of course Earth, which will be the stage from which you will be watching. It should be noted once again that all these phenomena are due to the perspective and the geometry of the orbits. Since our eyes cannot provide a 3-dimensional view of the sky, everything, planets and stars, will seem to be at the same distance, as if hanging on the celestial sphere. In reality, the distances involved during the alignments we are considering will range from 0.57 AU astronomical units for Venus to 10.3 AU for Saturn, 2 planets that will appear very close to each other in these evenings. Meanwhile, for the planets not visible to the naked eye, Uranus will be at 19.2 AU and Neptune at 30.5 AU. Late January, how and where to watch? To get the best view, let your eyes adjust to the dark for 20 to 30 minutes, and make sure to choose an observation site away from any light sources. Remember that planets can be distinguished from stars by their light, which is not as twinkling as that of stars. Additionally, planets move within the constellations throughout the year, while stars have a fixed position. When to watch? If possible, start observing the sky in the early evening, shortly after sunset, because Venus, Saturn, and Neptune, the planets furthest west, will gradually approach the horizon and become increasingly difficult to see as the evening progresses. Mars. On January 25th, Mars will be in the east, directly below the constellation Gemini. Mars has just reached opposition, meaning it will be at its closest distance of the period, 0.66 astronomical units. The red planet, which will indeed appear a deep red, will appear larger and brighter and will be visible at night. Mars is easily visible to the naked eye, but if you have a backyard telescope, you will be able to see many details on its surface, such as the polar caps. Since December 6, 2024, Mars has shown retrograde motion. This is when Mars appears to move backward compared to its normal eastward prograde movement in the background sky. By January 26, Mars will be south of the bright star Pollux in Gemini. During this period, Mars and Pollux will appear separated by just over 2 degrees, 4 times the angular size of the lunar disk. If you continue to observe Mars beyond this week, You will eventually see it move west of Pollux due to its retrograde motion. This retrograde motion will continue until February 24, 2025. After this date, Mars will resume its normal prograde motion, moving again towards the star. Jupiter. Jupiter will be west of Mars in the constellation Taurus to the left of the Pleiades cluster and about 4.45 AU away from us. Its brightness is impressive, second only to Venus. However, even a 20 times binocular will allow you to see its 4 major moons and perhaps its characteristic colored cloud bands. A backyard telescope will give you an even more detailed view of the giant planet. Try to spot the famous Great Red Spot, an anticyclone over 10,000 miles wide. The spot isn't always visible from Earth because Jupiter's days last about 10 hours, meaning the storm spends a considerable amount of time in the hemisphere opposite to the one facing Earth. Jupiter will be visible for most of the night. It will rise in the late afternoon and set between 3 and 5 a.m., depending on the observer's location. Uranus. To the right of Jupiter, with the Pleiades roughly in the middle, is Uranus, more than 18 AU away, with a magnitude of 5.7 at the limit of naked eye visibility. It's better to use a good binocular, with which you can see it as a tiny greenish dot. Neptune. Even further west and even harder to spot will be Neptune, 30 AU away, and with a magnitude of 8.0, meaning it will be at least 8 times fainter than Uranus. You'll need a fairly large binocular or a small telescope to distinguish it from the background stars. Venus. Venus, located between the constellations Pisces and Aquarius, will be extremely bright, appearing in the sky like a small beacon. It's impossible to confuse it with any other planet. A small telescope will also show its phase, similar to a crescent moon. Saturn. Saturn, in conjunction with Venus, will be slightly lower and to the left with its characteristic pale whitish-yellow color. A binocular will allow you to spot its moon, Titan, while a small telescope will give you the extraordinary view of its ring system, which, however, is currently seen almost edge-on from Earth. The late February alignment. The planetary alignment in February will be visible almost worldwide in the evenings around February 28, 2025, shortly after sunset. Some locations will have better viewing conditions as the planets rise higher above the horizon. Saturn, like Mercury, might not be visible in some locations due to its proximity to the solar disk. Note that February 28, 2025 is an average date based on when this event will be well visible for most locations worldwide. The perfect date to view the alignment may vary depending on your location. Compared to the late January alignment, this February event will see Mars having passed opposition, significantly less bright. It will also have moved westward relative to the stars due to its temporary retrograde motion. Jupiter will also appear slightly less bright, but will retain all of its best observational features and will still be within the Hyades cluster in Taurus. Uranus's position and brightness will remain unchanged, while Venus and Saturn will have shifted slightly towards the constellation Pisces, forming a small and spectacular grouping composed, in order from highest on the horizon, of Venus, Neptune, Mercury, a thin crescent moon, and Saturn, all within about 10 degrees and very low on the western horizon. Observing Mercury, the planet that brings the number of planets involved in the alignment to 7, will be challenging. In the late January alignment, the small planet was in close conjunction with the Sun and thus unobservable. However, the past month has made it possible for Mercury to be seen under the best observational conditions, absolutely clear horizon, perhaps with the help of binoculars. So, dear friends, while this may not be as spectacular as a total solar eclipse, if you can't look at the sky with a view that encompasses the different depths of space you're observing, I assure you that you'll feel a bit of excitement nonetheless. Let us know.